Hello everyone, I hope you're okay. Uh, and I really hope guys that the videos will keep uploading or helping you out. Just note that guys, this is the first video of me answering the past question papers with regards to acids and bases rather. I've compiled questions from past question papers and put them in one document. I've realized that I cannot do all these questions at a go. I'll just be able to make, let me see how many questions do I have. Yeah, that simply means I'll make 9 videos trying to help you answer question papers with regards to acids and bases. And I really hope guys that the videos will help you understand and master the topic, because it's not that deep. It's not that deep. Okay, question 1. Oh, before start, subscribe button. Okay, question 1. We are told that sulfuric acid is a diprotic acid. The first question says, define an acid in terms of Lowry-Bronsted theory. Lowry and Bronsted said an acid is a substance that ionizes in a solution to donate a proton or to donate a hydronium ion. Or you can simply say an acid is just a proton donor. Okay, 7.1.2. We are asked to give a reason why sulfuric acid is referred to as a diprotic acid. Sulfuric acid is a diprotic acid. Why? Because it ionizes in water to give away 2 protons. Yeah, it ionizes in water to give away 2 protons in this equation. It's H2SO4. I'll just write the complete ionization. I know it's a 2-step process. I'll just write the complete one. No? It's H3O plus SO4 2 minus. And then remember that it's a diprotic acid, which simply means I must have two protons there, and I must put a 2 there for me to balance the equation. Together. So sulfuric acid it donates 2 protons. This is the balanced equation of ionization of sulfuric acid. Okay, 7.2.1. We are told that hydrogen carbonate ion can act as both an acid and a base. It reacts with water according to the following balanced equation. Okay, we have HCO3 plus water. It gives us H2CO3 plus the OH minus. Okay. For the first question, they want us to write down one word for which the underlying phrase simply mean. Okay, the underlying phrase it tells us that this substance can act as both an acid and a base. That means that substance is an ampholyte. It has the ability to to accept a proton or to donate a proton. Together, you can either say it's amphiprotic. You can say it's an ampholyte or amphiprotic. 7.2.2, we are asked to write down the formula for the conjugate acid for this guy. If this guy acts as a base, remember that guys, whenever I focus on the forward reaction, this one is a base. Why am I saying that? Because it will accept a proton to become H2CO3. Are you together? And then water is an acid. Why? It has to donate a proton for it to become OH minus. And then whenever we forward on the reverse reaction, H2CO3 is an acid. Why am I saying that? Because it has to donate a proton for it to become for it to become a hydrogen carbonate. And then OH minus is a base because it has to accept a proton for it to become AeHO2. So this is a base. So remember that, guys, a base on the other side is conjugated to an acid on the other side, and an acid is conjugated to a base. Are you together? So to answer that question, the conjugate acid for this base is the carbonyl acid, H2CO3. Then let's go to 7.3. We are told that a learner accidentally spilled some sulfuric acid of concentration 6 mol per cubic decimeters from a flask on the laboratory bench. Her teacher tells her to neutralize the spilled acid by sprinkling sodium hydrogen carbonate powder onto it. The reaction that takes place is as follows. Okay, that's the reaction, and we are told to assume that the sulfuric acid ionizes completely. Okay, the fizzing due to the formation of carbon dioxide stops after the learner has added 27 grams of sodium hydrogen carbonate to the spilled acid. Okay, then now the question says calculate the volume of sulfuric acid that's spilled. Assume that all the sodium hydrogen carbonate reacts with all the acid. Okay. For us to be able to determine the volume of our acid, guys, we must be able to know at least the number of moles of the acid which is completely neutralized by the base. We do have the concentration of the acid. It was given to us as 6 moles per cubic decimeters. If we can find the number of moles of the acid, we can simply find the volume. Okay, but what do we have? We are given the mass of the base which completely neutralized the acid. So we can calculate the number of moles of our base. The relative atomic mass number for our base, we have 23 for sodium, plus 1 for hydrogen, 12 for carbon, and then 16 multiplied by 3 for oxygen. In total, we'll have 84 grams per mole. So I'll say 27 divided by 84. 27 divided by 84 grams per mole. I'll simply get 0.32 moles. So these are my number of moles of the base. The number of moles of the sodium hydrogen carbonate. But please, guys, remember that according to our balanced equation, I will need 1 mole of sulfuric acid for me to react with I need 1 mole of sulfuric acid in order for me to form products. Are you together? 1 mole of sulfuric acid should react with 2 moles of the sodium hydrogen carbonate. But right now I do not have 2 moles of sodium hydrogen carbonate. I have 0.32. I want to know how much of the sulfuric acid do I need for me to react with sodium hydrogen carbonate. So I'll just place an X there because I do not know the quantity that I need. So I'll just cross multiply. Simply have 2x is equal to 0.32. Then x is 0.16. So the number of moles of my sulfuric acid is simply 0.16 moles. If, guys, you are struggling with what I just did here, there's a playlist I created for it's I think if you can just search stoichiometry, there are 5 videos there whereby I teach how to do basic calculations in chemistry. They are very essential, guys, because in each and every topic you will come across these calculations. Please go there. I'll put the link on the description video, on the description. Please click the video and then go and watch. Okay, let's continue to the business. Remember that we are supposed to find the number of moles of the acid, right? We did. So the concentration, the formula for concentration says N over V. I know the concentration and I know the number of moles. I need to find my volume. The concentration is 6 moles per cubic decimeter. The number of moles is 0.16. I want to find out I want to find out the volume. So 6V 0.16, then my volume is 0.16 divided by 6. What do I get? I simply get 0.027 cubic decimeters. This is the volume, or I can simply say I have 27 cubic centimeters. It's up to me how I choose to represent it. Okay, then for the following question, we are told that the learner now dilutes some of the 6 mole per cubic decimeter of the sulfuric acid solution in the flask to make it 0.1 mole per cubic decimeter. Calculate the volume of the 6 mole per cubic decimeter acid solution needed to prepare 1 mole per cubic decimeter. Whenever, guys, you dilute an acid, you are simply adding more water to the acid, right? You are not tampering with the quantity of the acid. So the initial number of moles, whenever the concentration was still 6 mole per cubic decimeter, will be equal to the final number of moles whenever the concentration is now 0.1 mole per cubic decimeter. The only thing that changed is the volume of the container. Remember that our formula to calculate number of moles is this one, right? I mean, our formula for concentration is this one. So if ever I want number of moles, because I know that my number of moles will be unchanged, I'll simply say concentration times volume is the number of moles. So this thing simply means that the initial concentration multiplied by the initial volume is equal to the final concentration multiplied by the final volume. Are we together? The final concentration, remember, we're given to be 0.1, and the volume is 1 mole per cubic decimeter. The initial concentration was 6. I do not know the volume. So all I need to do is to divide both sides by 6 for me to find the volume. So 0.1 multiplied by 1 all over 6. What do I get? 0.1. I'll simply get 0.01 0167 cubic decimeters. If I can multiply this by 1000, I'll simply get 16.7 cubic centimeters. It's up to me how I prefer to write my answer. It's up to me. Okay, the follow-up question. We are told that during a titration, 25 cubic centimeters of the 0.1 mole per cubic decimeter of sulfuric acid solution is added to an Erlenmeyer flask and titrated with 0.1 mole per cubic decimeters of sodium hydroxide. Okay, the learner uses bromomethyl blue as an indicator. What is the purpose of the indicator? The purpose of the indicator is to indicate the end point of the reaction. When the indicator starts changing its color, we will realize that the acid and the base has completely neutralized one another. So that's the answer. To help us see the end point of the reaction. Then 7.3.4, we are told to calculate the pH of the solution in the flask after the addition of 30 cubic centimeters of sodium hydroxide. The end point of the titration is not yet reached at this point. Whenever they tell us that the end point is not yet reached, guys, they are trying to limit us that we must not use the titration equation, because you only use the titration equation if and only if the acid and the base have completely neutralized one another. If they haven't, do not use this thing. Do not use this thing. Okay. I think for me to be able to answer this thing, remember that, guys, whenever I'm mixing an acid and a base, the substance which is in excess is the one that will help me to find the pH of my solution, right? If even before I continue with this thing, let me write a balance reaction for this thing. I have H2SO4 plus NaOH. This will give us Na2SO4 plus water. Remember that, guys, whenever I mix an acid and a base, I must get salt and water. Okay, let me find out which one between the two is the limiting reagent and which one between the two is the reagent in excess. The one which is in excess is the one that will help us to determine the pH of the final solution. Okay, the number of moles for sulfuric acid, I'll simply take the concentration multiplied by the volume. My concentration is 0.1. The volume is 0.025. So therefore the number of moles 0.1 multiplied by 0.025. I'll simply get 0.0025 moles. Okay, and then the number of moles for my base, NaOH, its concentration multiplied by volume. The concentration is also 0.1, the volume is 0.03 cubic centimeters, right? 30 cubic centimeters. So I simply get 0.003 moles. Okay, between the two, one of them will be in excess and the other will be completely used up altogether. So the one that will be completely used up, we call it the limiting reagent. So for me to be able to find out which one between the two is the limiting reagent, I need to know which one will give me the smallest amount of product. The one that will give me the smallest amount of product is my limiting reagent. So what I'll do here is to say, I know that, let me use a different color. I know that one H2SO4 will produce one sodium sulfate together. But now I do not have 1 mole of H2SO4. I have 0.0025 moles, and I want to know how much will I form. I'll just cross multiply here. So X will be equal to 0.0025. Remember that X will represent the number of sodium sulfate that will be formed if I completely used up my acid. Okay, now let's check that if I completely use up my base, how much of the sodium sulfate will I form? 2 moles of sodium hydroxide will give me 1 mole of sodium sulfate. But I don't have 2 moles, I have 0.003. I want to know how much of the sodium sulfate will I form. I will cross multiply, then I'll have 0.003 equaling 2x. Then x is equal to 0.0015. Remember that x represents the number of moles of sodium sulfate that will be formed if my base is completely used up. Okay, we can all see that, guys, the base is the one that produces the small amount of the product. We can see that. So which simply means that the base is the limiting reagent. That means the acid is the one that is in excess. Are you together? So from here, I know that since I know that my base is the limiting reagent, I want to know how much of the acid will I need to use for me to completely react with the base. I don't know how much of the acid I need, but I know that for the base, the 0.003 will be completely used up. Are you together? Then all I need to do is to just cross multiply. I'll have 2x is equal to 0.003. Then x is equal to 0.0015 moles. Are you together? So these are the number of moles that I need to use for me to completely react with the base. Are you together? So I'll simply say the number of moles which were used are simply 0.0015 mole. So for me, remember that, guys, for me to find the pH, I must get the quantity which is in excess, because the substance which is in excess is the one that will help me to find the pH of my solution. So the number of moles of the acid in excess is simply the initial number of moles. Remember that initially we had 0.025, 0.0025 minus the used amount of moles, it's 0.015. So this thing simply means that in excess I only have 0.001 moles. These are the number of moles of my acid which are not used. Are you together? Yes, I can find the concentration of the final concentration of my acid, but I don't have to, because I know that I only need, for me to find the pH, I only need the concentration of my hydronium ion. Are you together? Remember that sulfuric acid, guys, is diprotic. Whenever it ionizes, it gives us 2 H plus ions plus SO4 2 minus. Are you together? So I can simplify the number of moles of the hydronium ions in the excess solution. How can I do that? I simply know that 1 H2SO4 will give me 2 H plus ions. Since I have 0.01, I want to know how much of the H plus ions will I form. I'll just cross multiply, then X will simply be 0.002 moles. But remember that X represents the number of the H plus ions in the excess solution. Are you together? So now, for me to find the pH, I must know the concentration of the H plus ions. I do know the number of moles. Now I want to find the concentration. concentration is N over V. Simply means the concentration of H plus ions, it's 0.002 divided by remember that, guys, now the final solution has both the acid and the base. So I'll simply add my two volumes there. I'll say 30 cubic centimeters plus 25. I'll get 55 cubic centimeters, which is 0.055. This will give me 0.002 divided by 0.055. This will give me 0.03636 mole per cubic decimeter. This is the concentration of my hydronium ion. So now I can simply calculate the pH of my solution. pH is simply minus the log of the hydronium ion, is minus the log of 0.03636. Whenever I punch my calculator, minus the log, I'll simply get 1.44 as my pH. So this is how, guys, this is how you're supposed to answer these questions, guys. Initially I wanted to do all these questions in one video, but so I'll just do them one by one. As you can all see that I explain things a bit slower. I can't talk faster because I stutter. Okay, please, guys, stay tuned and wait for more videos. Just know that there will be 9 more videos coming in, whereby we just need to calculate the pH. Danko.